Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are checking your answers. You had homework about pressure, paper 1 for core and extended candidates. Let's start by question number 1. We have 10 questions and question number 1 is discussing pressure of liquid. We have 4 identical beakers and equal volumes of liquids P and Q. Liquid P is more dense than liquid Q. Again, the concept, if you are checking or you are discussing pressure of liquid depends only on vertical depth of liquid, density of liquid. Okay? So here you are looking for point, its pressure, the least. Okay, so density of P is much greater than density of Q, and you are looking for least pressure. So you have to exclude liquid P and you have to compare between point C and point D. So liquid Q less dense, so the pressure will be least. Which point C or D, it has least pressure? The shallow one. Which one is shallower here? It's clear that point D shallower than point C. So the answer is D. Question 2. We have here different situations and we have force acting over a large area to produce small pressure. Back to our equation. Pressure is equal to force divided by area of contact or base area. So we have here different situations: a builder hammering a nail, a cook using sharp knife, a nurse pushing needle. All these examples representing very small area of contact, and we are here looking for case where the pressure is small. So decreasing pressure means the contact area or base area should be greater. So all the first 3 examples, they are examples for very small area, so they are exerting more pressure. Okay, so the correct answer for this one is a soldier marching in flat-soled boots. Question 3 is challenging question. Okay, we have here 4 solid pieces of same metal and they have same thickness and stands on a bench, but they have different base area. Which piece of metal produces greatest pressure? So we are looking here for greatest pressure. Back to our equation, pressure is equal to force divided by area. Okay, here we have 2 factors: the applied force, the force exerted on the bench, and we have here the contact area. Okay, we are looking for greatest pressure, so it means we are looking for greatest pressure means smallest area of contact. So it's clear and simple. What about the force? Force here is representing the weight of the object. and the weight of the object is equal to its mass times G, which is gravitational field strength or free fall acceleration. G is constant. It means increasing mass means more weight, right? What are here the objects which have more weight and more mass? Back to basics. What do we mean by mass? Quantity of material, the simplest definition, quantity of material in the object. So greater mass or greater weight, it's clear here that we have to exclude C and D. It's clear that A and B, they have more quantity of metal, more quantity of material, so they have more weight, so the force will be greater, the weight will be greater. Is it clear? Back to the second factor, which is the area of contact. Which one, A or B, it has least area of contact, the smallest area of contact? It's clear that A is here, the area is small. Okay, so A is the correct answer. Is it clear? This question is very important and challenging question. Question number 4, we have 4 physics teachers investigate pressure. They wear identical clothes and lie on different beds of nails. You have table, you have information about weight of teacher measured in Newton and total area of contact measured in square centimeter, which is okay. No need for conversion here. You have here to calculate. Why? Because you don't have constant factor. Back to our equation, pressure is equal to force divided by area. If the force is constant, we can use the relation that pressure increased, area decreased. If area is constant, okay, we can use the relation and the concept that force is directly proportional to pressure in this case. Okay, but here the two factors are changing, so you have to calculate. Back to calculations, so pressure is equal to force divided by area. The first one, 700 divided by 13, the answer is 53.8 Newton per square centimeter. The second one, you have 800 divided by 20. The answer is 40 Newton per square centimeter. Third one, third teacher, 900 divided by 14. The answer is 64.9 Newton per square centimeter. The last teacher here, 1021 is equal to 47.6 Newton per square centimeter. Which one exerting or experiences least pressure? According to your answer, compare. You have here 40 Newton per square centimeter, so the correct answer is B. Question 5, here we have a man stands on the ground. Which action will increase the pressure that the man exerts on the ground? The man slowly bends his knees. No, irrelevant. The man slowly lies down on the ground. Okay, it's relevant, but here the pressure will be less, not more. We are looking for increasing pressure. In this case, the contact area increased and pressure decreased. Okay? The man slowly raises his arms. Irrelevant. This will not affect the pressure. The man slowly raises 1 foot off the ground. Yes, because here he decreases the contact area, the base area, the area in contact with the ground. Okay, so the correct answer for this one is D. And the force here is the weight of the man. Question 6, we have a diagram showing 3 different containers, J, K, and L. Back to our principle. Pressure of liquid depends only on vertical depth of the liquid, not the tube or the container width or shape. And also it depends on density of liquid. Here we have different shapes of containers, but this will not affect the pressure of liquid. We have to check depth of liquid only. Which statement about pressure of water on the base of each container? Okay, it's clear that the pressure will be the same for all containers. Why? Because pressure of liquid is not affected by the shape of the container. It depends only on depth of liquid. Here, depth the same as here, the same as here. So the correct answer is D. Question 7, we have a diagram showing 4 divers at the bottom of 4 different swimming pools. 2 swimming pools contain fresh water and the other 2 containing salt water. Density of seawater more than density of fresh water. This question is asking you about least pressure, and pressure of liquid depends on density of liquid. So least pressure, so you have to compare the case where you have a swimming pool of fresh water because it is less dense. Okay, so you have to exclude C and D. Let's compare between A and B. The diver now in fresh water, which is less dense, and we are looking for case of least pressure acting on the diver. So the diver should be at shallow depth. Which one here is A is the correct answer, because here this is shallower than this one. Question 8, we have a brick with flat rectangular sides rests on a table. Now turned, so it rests on its smallest face. Now this case, we are changing the contact area, the base area, back to our equation. Pressure is equal to force divided by area, which is a constant factor here. We have here the weight of the brick here. Weight of the brick here is constant, unchanged. We are looking for changes that take place when the brick is now turned. What happened to the base area or the area of contact? Decreased. In this case here, the base area, the area of contact decreased if you compare it with the first case. Okay, so what will happen to the pressure? The pressure will be increased. The choices you have here, he's not asking you about the contact area, he's asking you about the force and the pressure. Force unchanged because it's the weight of the brick, but pressure increased. So the correct answer for this one is C. Force unchanged and pressure increased. Question 9 is challenging and is very important. We have polystyrene cube of mass 5 kg placed on horizontal table surface. The pressure due to the cube is 89 Newton per square meter. What is the length of the sides of the cube. Applying pressure is equal to, applying our equation, pressure is equal to force divided by area. Here the force is not given directly. The force here is the weight of the cube. How to find the weight of the cube? Weight is equal to mass times G. Mass is given in kilogram, which is okay. G, the free fall acceleration or the gravitational field strength, is equal to 10. So your answer is 50 Newton. So now you have the value of force and you have the value of pressure. You have to calculate area. Area is equal to force divided by pressure. So 50 Newton divided by 89 Newton per square meter. And you have to check that you have consistent units. Here we need your mathematical skills. Mathematics is the language of physics. Your answer is 0.56 square meters, which is one of the choices, this one, okay? But this answer, this is not the answer. Why? It's asking you about the length of the sides. So area of the cube is equal to length squared. To find length, you have to find square root your answer, which is 0.748 meters. So the answer is B. Is it clear? One of the common mistakes, some students, they just divide area by 2. No, it's not the right answer. There is a difference between 2L and L squared. They are totally different. Okay? So your correct answer is 0.75 meters, which is B. Question 10 is challenging and very important. A book has mass 400 grams. One of its surfaces measures 0.10 meter times 0.20 meters. This surface is in contact with the table, so it's the base area or the area of contact. The gravitational field strength is given. What is the pressure exerted on the table due to the book? Back to our equation, pressure is equal to force divided by area. This question is challenging. Okay. The force here, the exerted force here is the weight of the book, which is not given. So you have to calculate here the weight of the book, which is mass times G, and it's given here. And the area of base or the contact area 0.10 times 0.20. Okay, let's substitute mass is given in grams. So 400 grams to kilograms. You have to check you have consistent units. You can divide by 1000 or multiply by 10 to the power negative 3. I prefer you can use scientific notation. It will be easier. So 400 times 10 to the power negative 3 and G is 10. 0.10 times 0.20. If you simplify, you will find that 10 to the power negative 3, 400 times 10, this will be, if you simplify, it will be 4 times 10 to the power negative 3 times 10 to the power of 3. You can cancel out, and you have here 0.10 times 0.20. So your answer will be 4 divided 0.02, 200 Newton per square meter, which is the correct answer, D. Okay, this question is very important and is challenging.
Subscribe for more videos. I love physics blender. I love physics blender. I love physics blender. I love physics blender.